Okay, so we were here and we were discussing how we can find out the frequency and amplitude spectrum of a particular wave. So we saw that we summed it up. So this is a wave where we have summed up the 11 different waves. So all these 11 different waves, they are all sinusoidal waves. So this is the amplitude, this is the frequency, and this is the time. Similarly, here also we have this frequency, this amplitude, and the time. The unit of time, it is same, and also is the time intervals are all same, but thing is that we have different amplitudes and different frequencies. Okay, so we saw that there is one particular wave which has no contribution to the particular summation. So what we can do, we can increase maybe two more waves and see what happens. So whether the accuracy increases or not. So we will just quickly introduce two more waves. So control C and control V, and here we have to pull it down. So this will be 12, this will be 13. Let us introduce one more. So this will be 14. Okay, and similarly we have 12, 13 and 14. So here what we do, so this will be 12, this will be 13, and we insert one more. Okay, control C, control V, we have 14 here. Now we have to again change the amplitudes and the frequency. So here if I click, so I can see that time it is taking here. So G4 is not the time. So I can just, when this cursor changes to this one, so I can just pull it to whichever cell I want and it will be changed. In the formula it will be changed. Okay, so similarly here also I will pull it down. So should be 12, enter, and this is 11, yeah, and this is 12, then this is 13, and this will be 14. Okay, so here we introduce, so we saw that the amplitude 3, it is not contributing much, so it is 0 amplitude, so we can bypass that. So here what I will do, so maybe this 1, 2, so this is suppose 4, 5, okay, so 4, 5, and we pull it there. Alright, and here similarly, so 3 will not be required, so 1, 2, so 3 I will bypass, and 4, 5, okay, and here you see, so this now it is linear, so amplitude and frequency initially it is linear, so I have missed one point in between. So this is the summation here. So here what I can do now, so let us check whether the things are okay or not. So this is 11, so yeah, it is 11, frequency is amplitude and 11, this is 12, yeah, so it is okay, this is 13, it is okay, and this is 14, yeah, it is okay. So enter and double click and double click. And what about the sum? So sum, I will pull it here, all the 14 waves, enter and double click. So definitely the difference has now increased. Okay, so what we will do, so here you see, so it is now changed. Okay, so this is the summation of the waves. So I can copy that here, Control C and Control V here. All right. So we have this wave here, and this is the amplitude and frequency function, amplitude versus frequency. So it is now linear. So what I will do is now I will solve it again. So for this, minimizing this one. So go to data, solver, and then changing this one. So it is already there, W1 we have to change by changing the cell. So I will click here and come here. So pull it down, clicking, control, pull it down and solve. Okay, so it is given me some awkward result. So I will again change it. And again solve it. Again we got the same result. Alright, so it is, so here we see that 11 numbers of waves is the ideal waves. Alright, so more than that it is not helping. Okay, it is not helping. So what we will do, so here summation, yeah, it is there. So let us check if 10 numbers of waves increases the solution. So I will only consider only 10 waves. So sum up that one. So 10 waves I will sum up. So these 3 waves, these 4 waves basically they are redundant. Okay. So I am summing up only this 10, this 10. Okay, this 10 I am summing up. And we will again minimize that. So while considering that, we will consider only this 10. Okay, so this will be 0 and this will be 0. So let us keep this 0. Alright, and here what I will do, so I will consider only the 10 waves here. Okay, so these 10 waves I will consider. So let us again solve it. So solver, so it is already W1, we have to minimize, and here I will now change it for this 10 waves. Okay, control and this one and solve it. Okay, so not much of a improved solution. Okay, so if I take 11, so let us check. If I take 11, then it is giving the best result. So enter. Okay, so now we have 11, considering 11 summation. All right, so sum up this 11 now. So here also similarly I will change it 1, 2, 3. I will change the frequency up to 11 and 1, 2, 3. Change the frequency up to 11 and then solve it. So this is okay, and here up to 11, control to 11. Okay, and solve it. So it is giving the best fit solution. Okay, so this wave, when it was originally created, all right, so originally when it was created, so it may have had 11 numbers of sinusoidal or simple harmonic motions, which gave rise to the summation of that waves gave rise to this particular wave. So this is the amplitude versus frequency. Okay, so what we will do, we will make a copy of this. So create a copy. Okay, so we have created a copy. So now we have another waveform. So here we see, so this is the one. So let us try to get that one. So what is the frequency, amplitude, content of that, this wave? Okay, and we will compare the two. So what I will do, I will control shift this one, control C, control shift down arrow and control C, copy, right? And then I will copy it here because this is the time series. No, that is the this. Sorry, where was the wave? Here. Okay, so this one. So here we have to paste it. Okay, so here home, paste values. So the wave, original wave is changed. So now we are taking the other values, the other vibratory motion. Alright, so now again we will solve it. So let us solve it with 11 numbers of sinusoidal harmonic motions. Alright, so summation of that only. So again we will come to here. So data solver, that is already there. Minimize this one and solve. So it is giving us certain different results. Okay, so what we will do, so let us maybe increase the thing. So here we will sum up the entire 14 waves again. Alright, so let us check whether it gives us good result or not. So we will sum up the 14 waves. Okay, and here we will change the values. Okay, starting from a linear distribution, then again solver, so that is already there. So here we will again change this entire thing, control entire and we got an exact result. And here you see there are two peaks. Okay, so here we see that there are two peaks. All right, so this is the lower frequency. All right, and the amplitude is more, and this is the higher frequency, and the amplitude is a little bit less. So we have two peaks here. Okay, compared to the previous this function. So here, if you see this one, we had only one peak. All right. So one mode of vibration. Here we have two mode of vibration. Okay, two mode of vibration. So two peaks means two mode of vibration. 3, 4, 5 peaks means 3, 4, 5 modes of vibration. All right. So this is the natural frequency of the first mode, and this is the natural frequency of the second mode. Okay, so this is what it looks like. So what we will do, so we have certain earthquake time histories. Alright, so this is one time history of Chichi earthquake. Alright, so this is the Northridge earthquake which gave rise to the San Fernando Dam failure. Okay, so we have two earthquakes, Northridge 1 and Northridge 2. And we have the Kobe earthquake time histories. Poitiers narrows. All right, so we will see all that, and Loma Prieta. So these are some famous earthquakes, well documented earthquakes. Famous means well documented earthquake, well studied earthquake. All right, and it gave rise to a lot of disaster actually. So very unfortunate in case of history. But thing is that we have lots of things to learn from these earthquakes. So we got to learn a lot of things. So that is why it is well documented, well studied, and therefore it is available. All right. So first of all, let us plot this data. So we come to insert, and so I take this one, select data, add, x will be always time. So you can see this is the earthquake time history, acceleration time history. Okay, so these are all acceleration values, and in terms of g, so this is ratio of g. Alright, so acceleration in terms of g, that is. So this into g is the acceleration which is occurring there. Okay, so that is in terms of g. So one thing which you can directly find out is, suppose the coefficient of uh, acceleration. So kh. Alright, so maximum kh value. So directly you can find it out. So here if I equal to max. Okay, maximum. So maximum, I will choose this entire one and enter. Okay, so the maximum is, you can see, format cell. I will go to number and change it 4 maybe. So you can see it is 0.1829 times g. Okay, so 0.1829 times g. So obviously if we choose here, there will be another, in terms of the negative acceleration, so we have to go for the minimum then. So minimum, okay, so it is this one. So here you see, it is minus 0.155. That is, it is in the other direction, that is. Okay, and if I go to the topmost peak here, yeah, so 1.82, yeah, that one, that point it is showing me. Okay, so A max, that is, so A max is definitely this one, not this one. So in the other direction, definitely it is 0.1. So if I paste the format here, so it is in the other direction, the maximum acceleration is this one, coefficient of acceleration. Okay, that is in terms of g, so that you have to keep in mind. So now we have to analyze the frequency content of this. Okay, so what is the acceleration amplitude spectrum? All right, so that is why amplitude frequency spectrum. All right, so we have to find that out. So before that we will concentrate on the examples that we have been studying. So what we will do a Fourier analysis of this data.